Now, one of the downsides to using the AC method is that we need to find those two numbers to split the middle term up into. And that wasn't so bad when our coefficients were small. But suppose we want to factor 15x squared minus 4x minus 180. We might think, oh, well, those coefficients must have some common factor we can pull out first. But no, the only factors of 15 are 3 and 5. The only factors of 4 are a bunch of 2's. If we're going to factor this, it has to be as a product of two binomials, and it has to be using the AC method. But AC in this case is 15 times negative 180. What does that work out to? That is negative 2,700. I don't want to be in the business of finding all of the factors of that number by hand. So let's think about how we would go about finding all of the factors. Right, we go about finding all the factors of a number by, well, going through and dividing it by every number in turn. So we might say negative 2,700 divided by 1 is negative 2,700. So 1 times negative 2,700 is one factor pair. Adding them together, that's negative 2699. That's not what we want. Negative 2,700 divided by 2 is negative 1,350. So 2 times negative 1,350 is another pair. Add them together, negative 1,348. That wasn't what we want. But this is a boring, repetitive task, and we know someone who's really good at boring, repetitive tasks, namely the calculator. Here's what I'm going to do. I'm going to call the number I'll divide by capital X, because that's what the calculator calls its variables. Then the other factor is negative 2,700 divided by X. And the sum, the place I'm going to look for negative 4, is those two added together. So what's that going to look like in the calculator? I'm going to go to my y equals. In y1, I'm going to say negative 2,700 divided by x. And in my y2, I'm going to say x plus negative 2,700 divided by x. In general, you'll replace negative 2,700 by whatever AC is. Okay, and now what am I going to do with that? I'm going to hit second and look at the table. Of course, 0 says error because we're dividing by 0. And the place I'm going to be looking is in this y2 column. Why am I looking in the y2 column? Because that's where I put the sum. I'm looking for that number to be 4. Or rather, negative 4. Notice as I scroll down, that number is becoming less and less negative. Oh, there it is. There it is. My two factors are negative 54 and positive 50. So, I find that 50 times negative 54 is negative 2,700, and 50 plus negative 54 is negative 4. So I'm going to split up my negative 4x as 50x plus negative 54x. And now I'm going to set up my box to use the area method to factor. My x squared term is 15x squared. My x term I'm splitting up as 50x times negative 54x. And my last term is negative 180. Okay, first row, 15 and 50 have a 5 in common. And then x squared and x have an x in common. So I've got a 5x there. 5x times what is 15x squared? 5x times 3x. 5x times what is 50x? 5x times 10. Okay. 3x times what is negative 54x? Let's see. Negative 54 divided by 3 is negative 18. So negative 18 times 3x is negative 54x. Is it the case that negative 18 times 10 is negative 180? Yes, it is. So this really worked. My factors are 3x plus 10 times 5x minus 18. So what's the key point here? We can use the calculator to shortcut that tedious step of splitting up the middle term. What did we put into the calculator? In y1, we put in a formula to give us the second factor when x is the first factor. And in y2, we put in x plus the other factor. And then we scrolled through the table until we found that middle coefficient in y2.